Hi guys, and welcome to another chapter, this time on the equation of a straight line in intercept form. Yes, I was reading that from a screen. My apologies. My name's Darren. Welcome if you are new to my channel or new to my website. It's really good to see you. These videos are part of the Further Maths 3 and 4 course, which does not mean they're not relevant around the rest of the world. Please watch, and if you could, spread the word. Now, head over to YouTube if you could and subscribe. I'm never going to be rich, and I'm definitely never going to be famous, but you subscribing just lets me know that you're watching, and that's really all the encouragement I need to continue recording these videos. MaffsGuru.com is my website where all these videos are linked to textbooks and are easily searchable and have downloadable notes. Head over there and subscribe. It's absolutely free to sign up. What are we dealing with today? Well, learning objectives. By the end of this lesson, I would hope you have an understanding, be able to apply two questions. The following concepts. Understand how to sketch the equation of a line or the graph of a line given in intercept form. Now, if you remember, y equals mx plus c, that is gradient intercept form because it was given by gradient and intercept form. Whereas if I have something in the form of 4x plus 2y is equal to 8, for example, that is called intercept form. Why? Because actually we use that form of the equation to find the intercepts, the y-axis intercepts and the x-axis intercepts, which is pretty much what this video is all about. Now, yes, this is the general form of the equation of a straight line, but this is also a straight line. Do you remember simultaneous equations where we gave you 2x plus 4y equals 8 and 3x minus y equals 6, and we went, okay, then go away and solve them using the most complicated things you could? Well, the good news is I have a video coming up that's going to show you a much, much easier way of doing this and what simultaneous equations actually were. But writing equations in this format can actually be incredibly useful to me to help me sketch them using just the number 0, because when you multiply by 0, what happens? Things tend to disappear. So, intercept form, as I say here, if I had something like 2x plus 4y is equal to 8, and I wanted to try and sketch that, well, at this moment in time, I don't have it in a particularly nice format. I could try and rearrange it and get my gradient and my intercept, but that doesn't necessarily make things particularly easy. What I do know, building on from a previous video, is that all the points on the x-axis have a y value of 0. And all the points on the y-axis have an x value of 0. If you don't believe me, what do we know? If you plot 0, 4, 0, 3, 0, 2, where do they all sit? They all sit on the y-axis, yes. So when all of these values are 0, we know that it sits on the y-axis. How does that help us? Well, as I just said a moment ago, when you multiply by 0, things tend to disappear. So if I look at this equation here and I made y equals 0, what would happen? Well, I've got 2x plus 4y equals 8. Well, 4 times 0 is 0. And so actually, that tends to disappear, leaving me that 2x is equal to 8, and so x is equal to 4. Now, why is that important to me? Well, I've got a y value and an x value. And what's the only thing in the world that has an x value and a y value? Well, I'm sure there's lots more. But the point of it is coordinates. So here, I know I have a coordinate of 4, 0. Now, don't get confused. It's not 0, 4. We always do the x value first. So 4, 0 actually puts me here. Oh, it's an intercept. It is indeed. Now, what happens then if I let x equal 0? Well, running out of room, so let's delete this for a moment. If I let x equal 0 in the same equation, I've got 2x plus 4y equals 8. If x equals 0, that disappears, which gives me 4y is equal to 8, or y is equal to 2. Now again, do I have a coordinate? Yes, I've got an x value and a y value on that line. So 0, 2 would give me a value here, for example. So that's 2, and that's 4, and lo and behold, yay, I've got a straight line. This is why I absolutely love equations being written in this format. When I do it, I actually cover things with fingers. I know that seems really weird, but if I know that x equals 0, I cover it over. I sadly can't show you how to do this because the video doesn't quite work that way. So let's look at another example, because the more examples we do, the better. So I've got 2x plus 4y equals 10. Let x equal 0. Let's start with that one first. So 2x plus 4y equals 10. X is 0 means that that disappears. Gives me 4y equals 10. And again, the numbers don't have to be nice. So y becomes equal to 10 on 4, which gives me that y is equal to 5 on 2. Now what's 5 on 2? About 2.5. So I'm going to write in brackets 2.5. It's just going to make life easier when I sketch this thing. So that's x equals 0. So now let's make y equals 0. And we got 2x plus 4y is equal to 10. So y0, that disappears, leaving me that 2x is equal to 10. So x is equal to 5. Marvelous, I've got some coordinates. So I can draw some axes, and let's see what we have. We have the coordinate position of 0, 2.5. Where do we get that from? X equals 0 and y equals 2.5. So 0, 2.5, let's say that's 1, 2, 3, and let's do a kiss there then. And again, I'm making my scale big enough so that it's not all scrunched up. I can do that, that's good. What was my other coordinate here? 5, 0. Again, don't get it the wrong way around. X is 5, y equals 0. So what do we do here? Let's see, 1, 2, 3, 4, oh, 5. That fits perfectly. 5, 4, 3, 2, 1. Let's make that 0. And so 5, 0 puts a kiss here. And then using my dodgy method here, hopefully I'll be able to sketch that into a straight line. And actually, I'm fairly impressed with that if I do say so myself. Oh, Pachking. There we go, ladies and gentlemen. Intercept form. What about when given 2 points? Well, again, building on a previous lesson, not a problem. When I'm given 2 points, if you remember, the best one to use, or the best form of the equation to use, is y minus y1 equals mx minus x1. Now, it's important to notice here, these points are not intercepts. How do we know that? Because neither the x value nor the y value is 0 in either of those equations. So it's not as simple as it seems. And doing these questions, you've got to identify that in an exam. So what do we need to do first? Let's find my value of m, which is y2 minus y1 on x2 minus x1. So my y2 is 8 minus 5. And again, remember, it's that value minus that value on 6 minus 2. 6 minus 2. 8 minus 5 when I went to school is 3. 6 minus 2 is 4. So there is my gradient of 3/4. Now it's getting a little bit more complicated as we move through the chapters. We're now getting fractions. No one likes fractions. I like fractions. They're okay. What else do we need? Well, we know the y stays what it is, but we need a coordinate. Oh my goodness, which coordinate do I use? A or B? A or B? I'm just going to use A. So y minus 5 is equal to 3/4 of x minus 2. Now, ladies and gentlemen, this is a big video if I did this. I'll continue now. But basically what I tend to do now is I get rid of the stuff I don't like. Whenever I have a fraction, all right, I get rid of the denominator. And I know that this here is basically a divide by 4. And how do you undo a divide by 4? You multiply absolutely everything by 4. So I'm going to multiply this whole equation by 4. So that y becomes 4y. The 5 becomes 20. Now, because I'm multiplying that fraction by 4, then it leaves the 3. And that becomes x minus 2. Now, why do I not multiply the bracket by 4, or the insides by 4? Because I've actually multiplied the outside. Now, this is algebra, and if you're not sure what's going on here, there are other videos, either already on my channel or coming, that will explain to you how to do this in much greater detail. But it's a freaking awesome trick here, because what I now notice is I can multiply out this, and so that gives me 4y minus 20 is 3x minus 6. And what do I do now? Well, I've got to get it into the equation, or the form that the x and the y are on the same side of the bracket. Oh, sorry, the same side of the equal sign. So what I'm going to do is I'm going to add 20 to both sides to get rid of that 20 there. And that's, sorry, let's make that 3x minus 6 plus 20, which gives me 4y is equal to 3x minus 6 plus 20 is plus 14. And then I'm going to take away 3x from both sides. So I'm going to get minus 3x plus 4y is equal to 14. And ladies and gentlemen, there is my equation written in intercept form. Yeah, now again, because we normally have the x term followed by the y term equals the number term, that is fine. Now this is obviously going to take practice. Yeah, there's a lot in this. There is finding the gradient. There is using this equation here. Then there's this whole fraction stuff. Now obviously if you didn't have the fraction, life becomes easier. But there's a lot of maths in this particular section, and you're going to get this. You're a gun. But I'm pretty much sure that I'm done. So thank you very much for watching. If you haven't already done so, can you subscribe? I'm not going to be rich. I'm not going to be famous. But it just lets me know that you're watching. Head over to MaffsGuru.com and sign up there. It's absolutely free to do so. You can find videos. You can use textbook searches. You can, what else can you do? Download notes. But otherwise, as I say, I'm done. Thank you very much for watching. Have a really good day. And please stay safe. Bye-bye.